All right, this is AP AB and BC Calculus. We're doing Unit 5, Section 9, which is connecting a function, its first derivative, and its second derivative. So we're just going to do a handful of problems here today that relate the three to sort of give you an idea of what you might be looking at in some AP problems. So, all right, example 1. So which best describes the function f of x equals x cubed minus 3x squared minus 45x plus 135 on the interval from 1 to 2? Okay, so there's a couple different ways to do this. Because it's an interval, not a specific value, it's difficult to just plug in a number. Now, one thing you could do is you could use 3 halves if you want. You could plug in 3 halves to f of x and to f prime of x and to f double prime of x, and that would actually answer your question pretty quickly. It's largely whether you want to plug in a fraction or not, right? So one option, since all of these involve the function being whatever it is, whether it's decreasing or increasing or concave up or concave down or negative or positive, over the entire interval from 1 to 2, one option for dealing with this, and again, this is just an option, but one choice is you could try an x value. So one way to logically do this is you could try 3 halves in f of x, f prime of x, and f double prime of x, because that the sign of f of 3 halves and f prime of 3 halves and f double prime of 3 halves would answer this question. So either way, it's very clear to me that I'm going to have to find both derivatives, right? Because increasing and decreasing is f prime, concavity is f double prime, and positive or negative is the original function. So since I know I need all three, I would say a good starting point is to just go ahead and differentiate. So f prime of x is going to be 3x squared minus 6x minus 45, right? And f double prime of x is going to be a 6x minus 6. Great. So I would say that this is by far the easiest. So there's a couple different ways to do this. One way to do it is to just look at the fact that this is 6 times an x minus 1, meaning that it is 0. It is 0 at 1. It'll be negative before it's 0 and positive after, right? It's a line that looks like this, and it's 0 when x is 1, right? So if you recognize that before 1, this thing is negative, and after 1, this thing is positive, you can cross off the answers that have, sorry, I didn't mean to cross off the negative. Come on, brain. This is the second derivative, so you can cross off answers that have concave down. So, so on the window from 1 to infinity, which would be included in this window, f double prime of x is positive, which means you can cross off all the concave downs, right? So now you've down to 3 answers, right? Unfortunately, those 3 answers all still have negative or positive and increasing and decreasing as an option. The other way to do it, if you didn't want to just look at the sign chart, is you could have just found f double prime of 3 halves. If you had done that, you would have gotten 6 times 3 halves minus 6, which is 9 minus 6, which is definitely positive. Since that's greater than 0, you could cross off the concave downs. So now I've taken care of concave down. The next easiest one to deal with is probably f prime, right? So I'm going to go ahead and look at f prime. I can yank out a GCF of 3 if I want. You certainly don't have to. But if you yank out a GCF of 3, you end up getting this, which you could factor if you want. Again, this is entirely up to you and where you feel like your own skill set is. This thing has zeros at x equals 5 and x equals negative 3, right? So if you were to look at this thing on as a quadratic, it's a quadratic with a positive leading coefficient. You can see that on the window from 1 to 2, which is definitely where this window is, right? So 1 to 2 is in this window. You can see that f prime is negative. So f prime is less than 0 in the window from 1 to 2, right? You could have also figured this out by plugging in the 3 halves, and you would have gotten a negative. So once you know that f prime is negative, you're looking at f being decreasing. So you can cross out any answers that say increasing. Well, that crosses out another answer. So now we've got decreasing and concave up. The only real question is whether this function is positive or negative. So in order to figure that out, I really just have to look at the actual function that I started with, which is all the way up here. So the function that I started with is x cubed minus 3x squared minus 45x plus 135. Now you could either solve and see if this is positive or negative. Minus 45x plus 135, right? You could factor this, right, if you want. You could either factor this or you could just plug in 3 halves and see what happens, right? If you factor this, it does factor by grouping. It's not an accident. You can take out a minus 45 and be left with an x minus 3. So you get x squared minus 45 times an x minus 3. Double check that I have that. Yep, we do. All right. So you could then figure out where your zeros are, right? So you're going to get x is plus or minus root 45. X is a 3, and I don't know that that's worth it, right? So you could figure out where the zeros are. You could figure out that the square root of 45 is bigger than 3. You could say, oh, it's a positive cubic. It looks like this, right? So you could actually figure out that it looks like this, which means that in this window, which is where 1 to 2 would live, right? Like 1 to 2 would be in here, your function is positive. Now that's one way to do it, right? The other way to do it is to plug in the 3/2 and see that you get a positive number. Again, that's going to be a preference, right? You might want to do this, you might not want to do this, it doesn't really matter. I would point out that this is not an AP problem, this is a problem that I wrote for the calculus competition, which is why there's no easy right answer, like you can't eliminate the options. So if you plugged in, you could figure out if this was positive or negative. You could also plug in by doing synthetic division if that's more up your alley. So there's a lot of different options. Any of those are fine. Really, you don't care what value the remainder is, you just care if the remainder comes out positive, right? So if you were to do this, you're going to get a pretty big negative value here. 45, so you'd have to do 45 as fourths, which is a 180. This is going to be a negative 180 over 4. This is going to be a negative 189 over 4. When you multiply it, you're going to get negative 300 and a 240 and a 27. So 540, 567. I think you get something akin to this over an 8, right? But this number is bigger than this number, so this thing nets positive, right? So I get it. It's no fun to have to plug this in. But you should end up getting that this value is positive. And you can see that it was positive here, or it's positive if you plug in. And you'll figure out pretty quickly that because this isn't over a fraction, that this number is much bigger than any of these numbers. So it nets positive. These are all smaller by a significant margin. Or you could see it using synthetic division. So again, no easy way to knock out the wrong answers here because I wrote it and I'm kind of mean. So, all right, give this one a try. It's the same idea. Again, if you wanted, you could just find, you could use like x is 4.5 or 9/2. But again, you'll see that here you have f increasing and decreasing is about f prime. Didn't mean to make that a double. And concavity is about f double prime, right? So you're going to need to see all the derivatives anyway. So there's definitely an argument for just, gutting it out and figuring out what the derivatives are. So I'm going to differentiate once and get that f prime is 3x squared minus 18x plus 24. It's up to you if you want to factor it right now. I mean, you're probably going to factor it in the end, but it's entirely up to you. This is definitely a 3 times an x minus 2 and an x minus 4. So the two zeros are 2 and 4, which means if you look at a smile that has zeros at 2 and 4, since we're looking at the window from 4 to 5, we're looking at a window after 4, so it's definitely, f prime is going to be positive, so f prime of x is greater than 0 on the window from 4 to 5. So once you know that, you can cross off the decreasing ones, so it's not those two. My f double prime, which I probably should have done first because it was the easiest, it's going to have a 0 at x equals 3, right? If you set the 0 equal to 0 and solve, you'll see that it has a 0 at x equals 3. Because it's a line with a positive slope, it looks like this, meaning it's negative before the 0, positive after. So on the window from 4 to 5, f double prime of x is in this window, right, is greater than 0 from 4 to 5. So if f double prime is greater than 0, you can cross out the concave downs, right? So that takes out another answer, right? So we're now down to the point where it's got to be b or c, and it really hinges on whether this function is negative or positive, which is what we saw in the last one too, because I'm kind of a jerk. So really hinges on whether the function's negative or positive. This is the question. So again, doesn't matter to me how you figure out what f of 9/2 is. I'm going to go ahead and factor it because I think that's the easiest option. So I'm going to notice that there is a local GCF of x squared, leaving me with an x minus 9. and that if I yank out a plus 24, I also have an x minus 9. So I'm going to get x minus 9 times x squared plus 24. Well, this case is even easier because this is always positive. It's a sum of squares. So the only possible 0 is 9. I'm looking at a cubic that has it's a positive cubic, and its only 0 is at 9. It looks like this. So it's negative before the 0, positive after, which means that in the window from 4 to 5, which comes before 9, f of x is less than 0, so I want negative. It's answer B. All right. Here we are given the graph of f prime, not f. We are asked on which of the following intervals is f concave up and increasing. So again, f, not f prime. So your job here is to translate what's being asked. So f being concave up translates to f double prime is greater than 0, right? That's the definition. But that translates to the slope of f prime is greater than 0, right? Because slope is the same as derivative, which translates to the given graph is increasing. The given graph, which is f prime, is increasing. That's what we're looking for. So this given graph is increasing here and here. Okay, so that's the first bit. So again, that's f is concave up, right? F is increasing. Well, if f is increasing, that means that f prime is greater than 0, which means that the given graph is above the x-axis, right? Because f prime is the given graph. So we want when the given graph is above the x-axis. Well, that's going to happen here and here. So if we want the windows where both of those things are true, it's this window and it's this window. Well, this is 1, 2, 3, 4 to 5. So 4 to 5 is one window. 6, 7, 8, 8 to infinity is the other window. So since they don't give us a choice from 8 to infinity, so the answers that would possibly work are 4 to 5 and 8 to infinity. Well, they didn't give this as a choice, so of the intervals they gave me, the one that answers the question is 4 to 5. All right, go ahead and give it a try with the same idea, right? Here we want to know when f of x is concave down and decreasing. So remember, you want to clearly write what's being asked. So not just concave down, but f is concave down. Well, f is concave down means the second derivative of f is less than 0, right? Which means the slope of f prime is less than 0, which means that the given graph is decreasing, right? The given graph is decreasing. That's what I'm looking for. So decreasing would be here and here, right? I'm also asked when f is decreasing. Well, f is decreasing is going to mean that f prime is less than 0, which means the given graph, right, the given graph, which is f prime, is below the x-axis. So that's here. Sorry, didn't need to color that high up. Here and also here. Well, the only windows that meet both of those qualities are right here and right here, right? So my possible answers, that's 1, 2 to 3, so 2, 3, and so 2, 3, 4, 5, 6 to 7, and 6 to 7. So 2 to 3 or 6 to 7, 2 to 3 is not an answer choice, right? 2 to 4 is, but that's not right, so it's D, 6 to 7. All right, below is a graph of f of x. Which of the following statements is correct? Okay, so when you look at this, they're asking you about f and f prime and f double prime at the point where x is 2, okay? So keep in mind that f is going to be the given y values, right? Because this is the graph of f of x, right? It says this is the graph of f. F prime is going to be the slope of the given graph, right? And f double prime is going to be the concavity of the given graph. So you're not expected to find a numerical value for these three things, right? What I want you to notice here is that f of 2 is 0, right? That's given. So what's likely happening here is we're being asked to find a relationship between 0 and a positive number and a negative number. So what I want you to notice is that at 2, right, f prime of 2 is less than 0 because f of x is decreasing, right? You can see that it's going downward, right? And similarly, see how this is cupping upward, right? So f double prime of 2 is greater than 0 because f of x is concave up. So you now have one number that is less than 0, one number that is more than 0, and one number that is 0, which means you can write these in order, right? Because what's happening is a negative number is less than 0 is less than a positive number. That's 100% how it works. So in this situation, f prime of 2 is less than f of 2, which was 0, which is less than f double prime of 2, which was positive. So you're looking for f prime being smaller than f, being smaller than f double prime. So f prime is smaller than f is smaller than f double prime is right there. And also keep in mind that on a problem like this, attention to detail is important because it's very easy to pick the wrong answer after doing the right work. All right, so same idea. Below is the graph of f of x. Which of the following is correct? Okay, so again, we're looking at 0, right? Here in the last one we looked at where x was 2. Here we're looking where x is 0, right? And essentially we're being asked the relationship between f and f prime and f double prime at this point. Well, f of 0 is 3, which for the record is a positive number. F prime of 0 is 0, because there is a horizontal tangent line there, right? You can see that this is a horizontal tangent line, right? And f double prime of 0 is less than 0 because f of x is concave down. So I know that negative numbers are smaller than 0, which are smaller than positive numbers. So negative is smaller than 0, which is smaller than a positive number. So the negative number, which is f double prime of 0, is smaller than the 0 number, which was f prime of 0, which is smaller than the positive number, that was f of 0. So I'm looking for f double prime to be smaller than f prime to be smaller than f of 0, and that's answer E. All right. Example 4, given the graph of the function f of x, which could be the graph of f prime? Okay, so this is f, and we're asked which could be the graph of f prime. So the first thing I would suggest you do is I would suggest that you figure out where the 0 slopes would be. So we have horizontal tangent slopes around -1 and 1, right? So there's a horizontal tangent at x equals -1 and x equals 1. What that means is on the f prime of x graph, f prime of x, sorry, let me erase the f prime of x. What that means is on the f prime of x graph that is correct, f prime of -1 should be 0, and f prime of 1 should be 0. So when I look at my graph, I can see that here, that's not 0, it can't be A. I see that, and again, maybe it's not exactly -1, right? Maybe it's not exactly, oh, maybe, hang on, these aren't exactly -1, I take it back. All right, sorry folks, not a perfect graph. So this isn't exactly at -1, it's just shy of -1, and I think if I erase the line I drew there, we'll see that this is just shy of 1, right? So like just shy of 1, just shy of -1, so I take that back slightly. Okay, so I should have a 0 here and here, just shy of 1 and -1, which I do. These are both still contenders. But here, this is very much not 0, and this is very much not 0, so C is not in contention, right? Sorry, I meant for them to be at whole numbered values, but clearly my picture is not perfect. So these are still contenders. The next thing I have to look at is I should look at the slopes, right? So this is a positive slope, which means that before hitting this 0, I need f prime to be positive. Well, here, this is negative. So if this is my f prime graph, I need f prime to be positive, right? It's physically above the axis. Then I need it to be negative, meaning below the axis, which it is. And then I need it to be positive again, my f prime, meaning the slope of this graph should be positive. So sure enough, it's answer A. Now, you could also argue that this makes a ton of sense because the graph that I showed you seems to be an x cubed, and it would make a lot of sense for your derivative to be a version of x squared, right, which is what that is. But again, we're trying to walk through how you would figure that out if it wasn't a graph that you have memorized. All right, so this time I'm giving you the reverse. You've been given the graph of the derivative, which could be the graph of the original. Okay, so in this instance, what I can see is that the derivative right? So f prime of, let's say, negative 1/2-ish is 0, meaning that f of negative 1/2 has a horizontal tangent line. Okay, so I go to negative 1/2, I see a horizontal tangent line, okay. I go to negative 1/2, I see a horizontal line, okay. And I go to negative 1/2 and I see a horizontal line. Okay, so that information didn't help me tons. But I know that f prime is negative over here, which should mean that f is decreasing, right, before that negative 1/2. And then f prime is physically positive above the axis, so f should be increasing. So now I need a graph that is decreasing first and then increasing. Well, this is increasing, which is not what I want. This is not increasing. It's also not decreasing, which is not what I want. Right? So it's not increasing. It's not decreasing. It's not doing either of those things, right? This side is decreasing. Then it hits the 0, and then f increases, so this is the graph of your function. Again, you could probably intuit this because this is an x squared of some variety, and if you differentiate an x squared, you get a line with a positive slope. But whew, that's the basic gist of how you relate a function to its derivatives, all right?